So if you actually been looking for a way to actually encode your data, maybe there's some particular scenario, maybe your data has those type of string or text on them, so you need to actually encode them, because we all know that some machine learning models out there cannot actually handle this type of text input. So you need to actually encode them for them to actually turn to numerical values, because most machine learning models understand these numerical values really well. So most of the time this is actually I can say that is actually more advisable. So this particular video we are going to focus on three types of popular encoding out there. There are a whole lot of them out there. So the first is that of the label encoding. I will have that of the ordinal encoding, and the last is one-hot encoding. Some of all this encoding we have come in contact with them when we did our tutorial on that of the pandas. I say that pandas library in Python by using pandas to do that of data analysis. So consider this encoding is really important. It really falls down to a whole lot of importance. Let's say in a situation whereby male and female, you want to actually present one as 0, you want to actually present the other one as 1, maybe your colors and a whole lot of other things. So that's basically what we are going to actually do the example, and then we are going to actually understand how this works in the normal way, rather than just talking about the theory. So I have the data already. Let me just paste the data. So this data will make use of. We have the gender, that of the male, female, male, and then we have the age, we have the salary, we have a color. So this data, this is what we are going to apply that of our like I said, the label encoding, that of the ordinal encoding, and that of the one-hot encoding. I remember that all these guys they are inside of the pre-processing sub module inside of this of the Scikit-Learn. So to actually make use of them, remember that this is a pre-processing, so I can actually directly import them here. But importing all these guys when you are not making use of them can actually delay your Importing this guy when you are not actually going to make use of them can actually slow down your running of your script, because these guys are really heavy on their own. Importing the Scikit-Learn is very heavy on its own. So let me just actually comment this Scikit-Learn out. So I'm just going to make use of some what I want to actually make use at that point. So let me actually just comment this guy also, but I'm just going to copy this guy. It's really important. On this of the Scikit-Learn pre-processing, let me actually give speed down. I want to import that of the label encoder. The next we want to actually import that of the ordinal which is ordinal encoder, and also want to import one-hot encoder. I said this actually one-hot encoder. So these are the three guys that we actually need, which is the label encoder, ordinal encoder, and this of the one-hot encoder. So for us to actually make use of this label encoder tend to actually target a particular feature. Label encoder is actually a one-dimension type of encoding. It can't actually. Why am I getting error down here? Okay, because this is not actually being it doesn't exist. So label encoding, like I said, it actually targets one particular colon. It doesn't actually focus on multiple colon, unlike this of ordinal encoding and one-hot encoding. So ordinal encoding can handle multiple colons at the same time, which is, I can say, two-dimensional type of input. And same thing with this of the one-hot encoder. I can actually handle multiple colon, not just only one particular features at a particular time. So let's actually make use of this label encoder as starting point. Let's actually put it here. Remember our setup, which is the data. We turned it to a data frame. We printed out the data frame, which is our initial data frame, and then this is the model. The model we're referring to is what the class we're actually going to make use of in that of the Scikit-Learn, and then we fit and then transform it our data. So remember that we're making use of this of the label encoder. Like I say, label encoder make use of one colon, so you can't just come and put two colon or put the entire data frame there. So what we can actually do is to actually set one colon here. Remember, we want to target this of the color, so we're going to see how this label encoder works. Remember that how label encoder actually works is that actually each is going to, first of all, is going to sort each of the can say each of the list of the element or all the elements in a particular column. When it's done sorting it, it's going to assign a particular numerical value to it. The first element is going to take that of the 0. The second element is going to take that of the 1. Third element is going to take that of the 2. If any element appear multiple times, let's say the element that is on that of the index 0 tend to appear maybe somewhere around maybe row 20 something, is it going to get that of the 0? So let's actually see an example. Let's actually, we have here red, blue, green, blue tend to appear 2 times, and when we look at the alphabetical order, blue tend to appear first. So blue is going to be 0. This is going to be here is going to, after blue we'll have the green, after green we're going to have the red. So we're expecting to get something like 0. After 0 we should have 1, and then this should be 2, and this guy should still remain 0. So let's actually run that. Remember that we'll focus on this of the color. You can focus on this of the gender. So you can actually focus on this of the age, salary, it doesn't matter. It's still going to actually give it a particular I can say a particular numerical value. We tend to have a little bit of problem when we run our original data frame. We have shape of past value. Past value is 4.1, which is 4. I can say 4, and then index is already just 4.4. So we might not, just for our colon, since we know that we're just giving it one, so we can just copy this, or we can say our df the colon maybe index. You know that this is actually index 0, index 1, index 2, and the index 3. But rather than doing that, we can actually just set our colon to be that of the color. So we know that we're dealing with that of the color. So the colon will be giving that of the color, because you can see here, this is the colon. The initial was 4, and then what we're trying to set is 1. You can see it doesn't really make sense. So sorry for that. So what are the error we actually get? Let me explain that a little bit. Where we the actual colon that we had earlier, this our data frame contain, this our df value variable contain that of 4, I can say 4 colons. So when we actually the output, and then instead of assigning it 1 colon, we assigned it 4 colons, which that's where we got this 4.1. We passed 4 rows and 1 column. Meanwhile, what was actually expecting is 4 rows and 4 column, but we've actually fixed that. So we can see that from this of our color for our color colon, like I said, the blue should take that of 0. We know that blue is in that of the index 0, and this of the index 3. As you can see, 0 here, 0 here, and the green is in index 2, and then it's going to get 1, and the last it was red. So if it's something like maybe the color, maybe we have something like apricot, or maybe a different color. Apricot is going to take 0, the blue is now going to take 1. So this is how label encoding actually works. So for this of the ordinal encoder that we have here, how ordinal encoder works, they can take voice. What actually takes that of 2-dimensional array, and then it can actually take can handle 1 colon, 2 colon, 3 colon, and a whole lot of colons. So let's actually want to target on this of our gender and on this of our color by making use of that of the ordinal encoder. So we can come here, let's put another quote, so we can set multiple colons here. So let's actually say, you can see now we have the gender and that of the color, and then we were expecting to have this. So let me just copy this, going to be 2. Let's set it here. So this is going to be our colon. So we are going to make use of that of the ordinal. The way ordinal encoding is just basically the same way label encoding works. Only the difference is that ordinal encoding can handle multiple columns, while for that of the encoding can only handle one particular features or one particular column at a particular time. As we can see from our output, that this is the gender, this is the color. Like we expected earlier, the blue, which is in row 1, is still our 0, like you can see. And the gender, you can see that male was actually assigned 1 because in that alphabetical order where you can start from that of A, B, C, see that F tend to appear first. So F was given that of the 0. You can see female appeared there, and female also appeared there. And for that of the color, we actually done for that, like I said, they are just basically do the same thing. They are just doing the same thing, just that one ordinal encoder can handle multiple colon at a particular time, but meanwhile label encoding can only handle one particular colon. And this label encoding mainly be used when it comes to this label encoding is actually being used in our target, not in our features, because the target actually encode your target at times, so you have to make use of the label encoding. So you can see how this difference between this of the ordinal encoder and that of the label encoder actually work. You can actually write the script by yourself, just sort them, and they are going to assign each of the value, maybe by getting that of the index position, just assign it to them. Not really much on how this label encoding and ordinal encoding works. So the next thing we are going to have is this of the one hot encoder. Remember that this one hot encoder actually works similar in this of work differently compared to this of the ordinal and this label encoder. One hot encoder, how one hot encoder actually works is this: each of the data point we have, or say each of the elements that we're trying to encode, what is actually going to do is going to create a colon for them, and then that particular position that element exists is going to assign 1 to it. Meanwhile, the other remaining part of the colon is going to assign 0 to them. So let's actually see an example of that then, so we can actually understand it really more. So one hot encoder, we're not going to change anything. Remember that we're actually targeting this of the gender and this of the color, so we can actually turn it to a numerical value. So why do we get this error, raise value error shaped? Everything seems to be working well. Okay, sorry, there's some parameter that need to be set for this of the one hot encoder. It doesn't mean that what we actually did here was actually wrong. Just that some parameter that this one hot encoder expect us to actually set in, and we need to actually tweak some a little bit, because this one hot encoder tend to actually create its own separate features name. So features name automatically create defense table. So for it to actually do it, you can say sparse output. Tend to forget some of all these guys. Thanks for VS Code. We are going to set it to what? False. This is the first step. So we can actually try to get the new features that this one hot encoder actually created. Remember that I said that from each of the item, or I can say the element that we want to actually encode, is going to create a separate colon for each other. I can say it's going to now look like as if it's creating a separate feature, or I can say a separate table for each of them. But let's actually do that. I can say our new underscore what, can say colons. So we're going to say our this of our model dot what get under what feature underscore names underscore what out. If I can remember, this is actually it. Model or get which model is referring to this of our model right here. So want to get the features out. So which feature do actually want to get out? These two guys. So want to get these two guys out from inside of the feature, because there are a whole lot of features inside of this. So I want to get these two guys out. So now the colons they want to get the data frame. The colons that we're now going to set is basically going to be this of the new colon that we have here, which you can see our new what. Cool. So with this set in place, everything should look out good. So what we actually did here, we set this extra parameter, the sparse to be output to be off, to actually give out the output, and then we're going to directly go to that of the model. Remember that this will actually fit and then transform the model, so it need to be beneath it. So model will get the features name out. So we'll focus on this of the gender and that of the color, because that is actually the role that we want to actually we're actually trying to encode. So we'll get the features name out, and then we'll use the new column that we actually extracted from this of the model to actually give our new pandas data frame colons. This is going to be the output. Then we are going to give it the colon as the new feature. So from what we can see here, see that this female, you can say gender, we can say the gender female, you can say that this gender was the sub colon name, and then we'll have this male. Like I said, each of the elements is now going to be created and be given a new colon. I can say this of the gender female is now given its own colon. Where female exists is going to assign 1 to them. Like you can see here, it existed on that of the row 1 and then existed in that of the row 2, like we can see here. So it assigned 1 to them. And for where did the male exist when it comes to this of the male, it signifies that male existed in this of the row 0, which is here, and that of the row 3, which is here. And for those of the color, now we'll have this of the 3 colors here, which is the blue, green, and red. So we can see that blue existed in this of the row 1, which we can actually see, and that of the row 3, as we can actually see from our original data frame here. And for that of the green, is actually appeared on row 2. Let's actually know whether that is true. Actually appear on that of the row 2. And the same thing happened for that of the color red. We appeared on just of the only row 0. I think that's so. As we can see, this is a one-hot encoder actually works. It works different from that of the label encoding, and different also from that of the ordinal encoding. The way one-hot encoding actually does is actually to each of, like I said, each of the elements that is going to encode is going to create a separate column for it. Like as if for this gender that we have here, only 2 elements existed, which is the male and female, and then he created a table for them where they exist on that of the, I say, data point, or maybe a row. It was being assigned 1 for each of them. So where they don't exist is going to assign 0. So you might be wondering the use case of this one-hot encoder. This one-hot encoder can have a really use case, because in a scenario, some machine learning can tend to actually, the more occurrence of the particular element on a particular row, like I say, a particular column, a particular features, or a particular set of numbers actually has something to do with that of the target. But when it comes to this of the one-hot encoder, what one-hot encoder actually believes is that every element should have its own table. So no model can actually tend to weigh more over the other. So the use case of encoding depend on your choice. Some people prefer this hot encoder, some prefer label encoder, some prefer ordinal encoder. So ordinal encoder and the label encoder can be a little bit beginner friendly, but this one hot encoder, I bet you, is one of the most advanced use, and can be really overwhelming for maybe if you are still new into that or the machine learning field. So actually just stick with your label encoder and ordinal encoder for the meantime, but as you gain more knowledge, you can dive into this one hot encoder. I remember there are so many encoders out there that you can actually use to encode your data, so not just only basically on this thread. So this for this thread actually settles for our encoding, because this of our Titanic data set that we have here, we're still going to do all these guys that we actually did, starting from this of the simple imputer to KN imputer, standard scalar to mass scalar, label encoder to ordinal encoder. This is what I want us to do it on a smaller scale, so it will be easier for us to understand. So that is basically the reason why I want us to do it in this smaller scale. So if you are still new, you won't get scared. We are going to look at how you can actually select a feature, like the feature that tend to be more important compared to the other ones. So in case, for example, when we look at this salary, let's say our target is the salary, and then maybe we have something like years of experience. Know that years of working in a particular company can actually determine your salary. So that salary can be a key to your to a successful output, to get your successful target, to make your model to predict really well. So next video we're going to look at how you can actually select the best features rather than having some useless features, not actually useless, some noise on your data that actually doesn't contribute to any performance of the model, that can actually lead to that of the overfitting and underfitting. We're still going to come to these two guys now as we go on. So this should conclude it for the encoding. I'll be happy to see you in the next one.